Question number 9. This is graph displacement y against distance x for progressive wave propagate to the right. So meaning here the direction of the wave is to the right, and the string in with the mesh 950, and the length of the string is 3 meter and the tension is 15. So meaning here we start with the string, and you can produce a progressive wave, right? Direction to the right, and this is the graph. So meaning, look at the graph here. So this is a maximum displacement, meaning here we have a amplitude, and this is a one complete. This is a refer to the lambda, right? This is one here lambda. Okay, so the question asks you to calculate the progressive wave. So progressive wave equation or general equation for progressive waves, as we know, is a y in function x t is equal to a sine omega t plus minus kx. So now the amplitude here is this is 12 and this is cm, so this is 0.12 meter, convert to the SI unit, and this is sine. So what is omega and what is the value of the k? And here we, because the direction of the wave is to the right, so maybe we can use the negative sign. So, and the first is how to calculate k. So to calculate the k, because as you know the k is a 2 pi over lambda here, and we know the lambda here is equal to, this is 50, so here is a half, so meaning this is 50 divided by 2, so here is a 50, because this is centimeter, convert to the meter is times 10 power of minus 2, and half of 50, right? This is lambda, and here you can find the value of the k here is equal to 25.13, right? So what is the omega? So I write here, so what is omega? So to calculate the omega, as you know, omega is equal to 2 pi f. From the information given, we have the mass of the string, we have the length L, we have a tension. So meaning here, because we know the value of the okay, to calculate the omega, we try to calculate the frequency. The frequency is come from the equation. Speed of the wave is f lambda, because lambda refer to diagram here is equal to 50 half, 50 convert to the meter is minus 2, and then now what is the frequency here? Okay, so to calculate the frequency we can use the v here, right? So according to the equation for the speed of the waves relate to the tension of the string is square root 2 divided by tension divided by nu. Nu is a mass per unit length. So mass per unit length, because this is a 950. Nu is mass per unit length. This is nu is a mass per unit length. So here we have a mass is given by the equation 920. This is gram, convert to the kilogram is times 10 minus 3, and here L is a 3 meter. So now you can find the value of the nu. So what is the tension? Tension is given by the equation 15 Newton. So now you can find the value of the V here is equal to 9.69 meter per second. So again we refer to the equation here. Okay, so V here is equal to 9.6.96 is equal to F, and the lambda is a 50 convert to the meter, and half of 50, because this is half of 50 lambda here. So now you can find the value of the frequency is equal to 27.84 Hertz. So now back to the equation here, because as you know, omega is equal to 2 pi f and the frequency is 27.84, so meaning you can find the value of the omega is equal to 1.75. This is exponent 2, exponent 2. So just the frequency here. So the final equation is y is equal in function xt is equal to, here is a 12 amplitude, so convert to the meter is 0.12 sine omega now is a 1.75 exponent 2 time t minus because propagate to the right, and the k here is equal to 25.13x, and the unit y is a yes, meters, no need for you to calculate. So this is the final equation, progressive wave. Okay class, continue to the number B. A 1.53 meter closed pipe make a sound frequency 282 Hz when the wind blow across open end. So this is closed pipe, meaning the one of the end of pipe we have a open end, right? So meaning here we have this is closed and this is open pipe. So for the situation, the length of the closed pipe is given by the, this is 1.53 meter, and the speed of the sound is constant 340 meter per second, and the mean frequency is 282 Hz. So now to calculate the number of notes here, first you must know what is the fundamental frequency or F naught. So this is a closed pipe, meaning for the F naught here, fundamental frequency F naught is given by the equation speed of sound divided by 4L. L is length of the pipe. So here we can find the value of the fundamental frequency is V. The speed of sound here is 343 and L here is 1.53. So now you can use the calculator to calculate the F naught or the fundamental frequency is 56.05 Hz. So now for the closed pipe, harmonic frequency you can refer to the relate to the fundamental frequency by the equation F is equal to F naught, right? Okay, so this is a fundamental frequency. We have already calculated F naught is equal to 56.05, and the frequency, how many frequencies? At frequency 282 Hz. So meaning here, if you calculate the value of n here, because n for the closed pipe is for the closed pipe, n here is referred to the odd number. This is 1, 3, 5. So here, if you calculate the value of the n is equal to 5, right? So n is equal to 5, meaning is referred to the n is equal to 5 is referred to the fifth harmonic, right? So the fifth harmonic, and for the n, the fifth harmonic, if you draw the diagram here for the fifth harmonic, so this is the first harmonic, right? So here we have a, right? So use the blue color here, right? So this is a first harmonic, right? So if you look at the for the first for the so if you look at the diagram here, because the fifth harmonic, if you look at the value of the n here, right? Because you can use f is equal to n f naught, right? Right? If you use the value of uh, f naught here is equal to 56.05 Hertz and fundamental frequency, so the frequency given here is 282, and now you can find the value of the n is equal to 5, right? N is equal to 5 is referred to the second overtone, or is referred to the fifth harmonic, right? If you choose the diagram for the fifth harmonic, so we have the second fundamental of harmonic, and we have the refer to the first overtone, and this is second overtone, or refer to the fifth harmonic, and you can find the value of the note here 1, 2, 3. That's why number of note is equal to 3. Hi, continue question number C. The frequency of visual by the moving trains and the frequency heard by the stationary observer is 520 Hz and 460 Hz. If the speed of the sound in the air is 343 meter per second, calculate the speed of train. So meaning here, so let's say this is a observer, right? Observer is a stationary observer, so meaning this is no speed of the value of the value of observer is equal to 0, and we have the, let's say this is a train, and is it train observer move forward to the observer, or the train is this is move forward, moves forward reach to the observer, or moves away, this is MA, right? Away, meaning here is a move away from the observer. But if you look at the frequency received by the observer 450, and frequency source frequency source is 540, and frequency heard by the observer is 460. So meaning here frequency of received by observer is 460 Hz, and the frequency source is 520 Hz. So meaning here of frequency observer less than frequency f source. So meaning here, if the f naught is less than f source, meaning the source move away from the observer. So this is speed of source. And if you look at the equation for the Doppler effect here, f naught is equal to v plus minus v naught divided by v plus minus vs, right? So this is a vs, speed of the source. This is speed of the observer, because the observer is stationary, so meaning here this is equal to 0, and sorry, this is time frequency source, right? And so what happened to the plus minus here? So plus minus, because the plus minus here, because this is 0, sorry for you to consider here, because 0. So what happened to the plus, the minus here? So for the v plus minus vs, so we must choose the, because move away, so move away is a f not less than fs, so meaning here you can use the plus, right? And the speed of the source, because the speed of the train, so this is the question asks you, So what is the speed of the train? And the frequency source is 5 to 0, and the frequency received by the observer or heard by the observer is 460. So now this is a speed of sound is constant 343, and here is also 343, and you can use the calculator to calculate the V as a speed of the train is equal to, this is 44.74 meter per second. Okay, thank you.